Okay, so this is the last video of week 1, 2.8, and I'm going to do the first one and then skip 12 each time until I get to the end. So the new, or maybe not new to you, but at any rate, the thing that we're doing, it's called composition of functions. So you may have seen this before. It looks like this. This means composed with, and what this is f of g of x. So you take whatever g of x was and you plug it in now to f. So if, say, then g of f of x is g of x squared plus 1 is, so you put that where the x is, like that, so x squared minus 2. You might also prefer to write it like f of x minus 3 and then plug in. So same thing, just depending on whether you want to write f of x first or go ahead and plug in first. And then oops, well, okay, so f of x was, so if we do it in the opposite direction, f of g of x is g of x squared plus 1, because whatever you plug into f, you square it and add 1. And now I'll just plug in x minus 3. So that's x squared minus 3x minus 3x plus 9 plus 1. Okay, so this is what composition is. Whichever one is on the right is the one that gets plugged into the other one, and you can compose as many times as you want. You can do, and that's f of g of h of x, like that. You can have 80 of them. You can have infinitely many of them. You won't in this course, however. So I'm going to look first at number 1, and so f plus g. Whenever you see, instead of composition, if you see plus, minus, times, divide, so the rules are f plus g of x is f of x plus g of x. Same with minus. Fg of x is f of x times g of x, f over g of x, f of x over g of x. So these kind of all do exactly what you'd prefer that they do if you were able to just define however you wanted them to. So f of x is absolute value of x, g of x is negative 7. So f plus g of x equals f of x plus g of x equals absolute value of x plus a minus 7. So absolute value of x minus 7. Okay, and then we want to figure out which one of these is that. Remember from the transformations and the parent functions, we're at least going to want it to look like absolute value x, so it's got to be one of these two. But the minus 7, because it's on the outside, not next to the x, but on the outside of the function, that means it goes down 7. And normally it crosses here at 0, 0, so this one's gone up 7. We want the one that went down 7, so it's C. Okay, so 13, we want to evaluate the function for the given value. Okay, so we are going to want first g over f of 0. So that's g of 0 over f of 0. G of 0 is the absolute value of 0 minus 6. F of 0 is negative 5 times 0. So 6 over 0 is undefined. If 0 is on the top and not on the bottom, then it's 0. If it's on top and bottom, it's indeterminate form. If 0 is just on the bottom and a different number on the top, then it's undefined. Basically, because if you have, what division does is if you have, say, 6 over 2, this says if I have 6, how many 2's do I have? And the answer is I have 3 2's. If it's, say, 1 over 2, if I have 1, how many 2's do I have? I have half of a 2. Okay, so that's what division does. So if I end up and say I have 6, how many nothings do I have? Then you could kind of make an argument for anything you want. Maybe I have infinitely many nothings, maybe I have no nothings, maybe I have 27 nothings. There's not an answer. So it's undefined. Thought there might be another part to that, but there's not. The difference quotient, you may or may not have seen before, but we talked about it slightly in the previous video. Well, not directly. So I mentioned in the previous one that if you have, say, A, f of A, and B, f of B, so this is just 2 points on the graph of f, any 2 points, then the average rate of change, which is slope, so y1 minus y2 over x1 minus x2, the first y is f of A, the second y is f of B, and then down here we have the first x minus the second x. So this is the average rate of change between 2 points. The difference quotient is a kind of special way of writing average rate of change between 2 points. It actually comes to more of the meaningful thing in calculus, but it's saying, okay, take x, f of x. So this is some point that you care about. And then I'm just going to pick a different point, any other point. But instead of calling it A or B or something, we're going to say it's x plus h. H may be negative. This may be less than x. It may be positive. It may be more than x. This just says it's different from x. And then its y value is f of x plus h. So then if we do y1 minus y2, and I'm just going to do this as our first, we have f of x plus h is our first y, f of x is our second y, and then we have x plus h minus x. And so the x's cancel. And this is the difference quotient. And it's basically it gives us a way to do it divided by the change in x without subtracting. And then you always note that h isn't 0. But if h was 0, then this would have been x, and we would have just been writing the same point both times. So h is never 0, but this is the difference quotient. So we want the difference quotient for this. So f of x plus h is minus 9, I'm going to put x plus h where the x is, squared, minus 7, put x plus h where the x is again, and then plus 5. So that's minus 9 times. I'm going to go ahead and square this, so I'm foiling x squared plus xh plus xh plus h squared minus 7x minus 7h plus 5. Be careful with this because a lot of times what people do is say this is x squared plus h or x squared plus h squared. It's not. You do have to FOIL it. It's a binomial. So minus 9x squared minus 18xh minus 9h squared minus 7x minus 7h plus 5. And right now you're thinking, holy heaven, this is terrible, but the numerator of our thing is actually f of x plus h minus f of x. So we have all of this. I'm going to put quotes here because I don't have room. So it's all of this minus 9x squared minus 7x plus 5. So that's all of this plus 9x squared plus 7x minus 5. So this negative 9x squared and the positive 1 cancel, the negative 7x and the plus 7x cancel, the 5 and the negative 5 cancel. If you have anything left that doesn't have an h in it, you've made a mistake. So everything that's just x's should cancel. So this equals negative 18xh minus 9h squared minus 7h so this is our numerator. Because in the end I really want f of x plus h minus f of x over h. So negative 18xh minus 9h squared minus 7h over h. I can factor out an h on the top and I can't factor out anything else. Well, I could factor out a minus, I guess, but so h, negative 18x, minus 9h because there are two h's there, then minus 7. And this is the part where it simplifies. So this is why if you have anything in it that doesn't have an h, then something's wrong, because the whole goal is going to be to cancel out that h. So unless I lost something on the previous page, this should be this. Okay, 37. So we have functions n and p, and we want n composed with p, and then we want the domain in interval notation. So domain issues that I talked about before, so we only really have if it's a denominator or if it's in an even root right now. In this particular case, so in the case of the composition, we need to be able to plug it into the first one, so p, and we need to be able to plug it into n of p. In our case, we're not going to have, at this moment, we're not going to have any domain issues. It's going to be all real numbers because we've got a polynomial and a polynomial. So there's no, and it's composed with. So there's no divided by and there's no roots. But if there were, you would just need to make sure that at every stage that you would plug in an x, that you get a defined result. So we would have to check, let me just, because you would have, we want this, we'd have to make sure that x could be plugged into this. So if this had a denominator or a root, we'd have to concern ourselves with its domain. But we also would have to be able to plug it into this. So we'd have to check the domain of the entire thing once it was out and simplified. Okay, so n composed with p of x is, n of p of x is, so what n does to anything in its parentheses is just adds 9 to it, so that's p of x plus 9. So now I'm going to substitute, and it's just this. So now this is a quadratic. Its domain is all real numbers. P of x to begin with was quadratic, so it's was also all real numbers. Okay, so now it wants to have the domain in interval notation. It doesn't have a symbol for all real numbers, so we're going to have to put negative infinity, comma, infinity. And remember, open parentheses because you can't include infinity because it's not a number. Okay, 49. We're given the graphs of f and g, and we want to find the function values for the given values of x if possible. So we want f plus g of negative 1. So that's f of negative 1 plus g of negative 1. We end up parentheses there. Okay, so f of negative 1. I go over to negative 1, and f is the blue. So at negative 1, it's right on the axis there, so that part's 0. G of negative 1, I come down to the pink line, and the y value is negative 2. Okay, so now we want g minus f of 0. G of 0 minus f of 0. G of 0, I go down to the pink line at 0, and it hits negative 3. F of 0, I go x equals 0, go up to the blue line, it's 1. G times f of negative 3. So g of negative 3, I go over to negative 3 and go to the pink one, it's negative 1. F of negative 3, go over to negative 3 and go to the blue, that's negative 2. Multiply them together, positive 2. and f over g of 0 f of 0 is still 1, g of 0 is still negative 3, okay, f composed with g of 3 So in this case, I don't have to do kind of the algebra with the x's. I can just go look at g of 3. So I go over to 3, and g is the pink one, so that's 0. So f of 0, and f of 0 is 1. G of f of negative 2. So negative 2. Go down to f, the blue one, so that's negative 1. We'll go to negative 1 and go down to the pink one. That's negative 2. And g of f of 2. So f of 2, we go over to 2, up to the blue, so that's 2 also. So g of 2. Go back over to 2, go down to the pink line is negative 1. $61. So in the graph we have P and R, which is total enrollment in millions for public and private schools in a certain country. So P is for public and R is for private. The variable X, weird little blip there, represents the number of years since 1990. We want to find T of X, which is P plus R of X. So T of X So that's what we're given. So that's P of X plus R of X. So 0.7x plus 47.6 plus 0.3x plus 9.6. So 0.7x plus 0.3x is x. 47.6 plus 9.6 is 57.2. Okay, and so T of X, if we take all the people enrolled in a private school and all the people enrolled in a private school, I think I said public first, but if we take all the public and all the private enrollees and add them up, then what we get is the total enrollment period in the country. So public and private school together makes T, which I can only assume is for total. Last one, 73. We've got f, g, and h, and we want f of g of f of x. So this is h of, there are a million orders in which you can do this. I'm going to leave the f of x. I'm going to just substitute for this part right now and leave the h hanging on out there. So g cubes whatever you give it. So that's f of x cubed. I may have excessive parentheses going on. I actually don't think so though. So that is h of. Now I'm going to plug in f of x, 5x plus 8. Okay. And then what h does to whatever's plugged into it is it takes the fourth root of it. So fourth root of. I don't see any reason for you to cube that. That would be possibly a crazy thing to do. So I think we would just put it in just like this. Or the only other thing you might do, depending on how it asks you for the answer, is say, well, this is 5x plus 8 to the 3/4. That's the only other thing you might consider doing. So let me see what I can get here. Okay, I'm going to do it this way, and I think that'll be fine. There. Fourth root of, parentheses, try again, 5x plus 8 and that's it. So that wraps up this section, and I will see you all Tuesday.